So I have a question for you. How many combinations of 4 digits do you have that can be accepted as a correct PIN number for your card? Do you have any ideas? Like, who thinks you have a single unique PIN number? What about 2 PIN numbers? 3? Do I have 3 or 4? Do you know an urban legend that tells that if you enter your PIN number in reverse order, that police is called to your exact location? Have you heard it? Yes. Well, it's false because my PIN number is the same from both sides. Yeah. Okay, so we all know that we enter the PIN number into some device. It might be ATM or a POS-terminal. So and then this PIN number in encrypted form is transferred to your bank. But what's not visible is that most cards on this magnetic track have a magnetic stripe and track number 2. They have something called PIN verification value, or it's PVV, and it's 4 digits long. So this data is sent to your bank as well, and it is used to verify if your PIN number is correct. So now it's most of the cards are chip cards, but chip cards also have a kind of emulation of this magnetic stripe data. And this PVV is the most common method. There's also a method called IBM PIN offset that is used to verify the PIN number, but I haven't seen it used for PIN verification. So PVV is the most popular one. So what it is? So PVV is calculated by taking your card number, then something called the PIN verification key index, which is typically 0, a constant. And then it takes your PIN number and encrypts it with a PIN verification key, and then somehow picks out the PVV number. So the most important thing is that the input is actually 8 bytes long, but the output is only 4 digits long. So if we take 8 bytes, that's 64 bits, and reduce it to 14 bits, what do we get? So it's like a hash function. What is a common problem for hash functions? Collisions, correct? So I did a couple of experiments by taking a random PAN number, random keys, and calculating these PVVs. So for 10,000 inputs, that is every PIN number from 4 zeros to 4 nines, we get only 6,500 unique outputs. And the same principle applies. It doesn't matter what the card number looks like, what the encryption key is like. It's about the same proportion. And if we look at these collisions in a bit different way, so here are about 30 to 40% are really unique PIN numbers. Then about the same amount of PIN numbers that actually have a duplicate. Then there are kind of a large set of 3 PIN numbers that all produce the same PVV value, and so on. And for each card, you can find a set of 6 PIN numbers that all produce the same PVV value. So according to statistics, half of you should have at least 2 PIN numbers. Yes?
It wasn't really clear. Are banks forced to use
Yes.
this function?
Yes.
But in that case, how does it work when some banks allow to change the PIN number? Because you change it through application or through the website, then you put in the card somewhere in some, I don't know. Sorry. So if banks were forced to use actually this hash function, then it wouldn't be possible to change the PIN number because through the website without overwriting it in the card.
I didn't want to talk about this, but the thing is that the bank knows what is your PVV for your current PIN, and then it calculates what would be the PVV for the for your newly selected PIN, and then it stores the difference or the new PVV value. So so it doesn't rewrite the data stored on your card, but it when the PVV comes in, it applies the difference function. It applies the difference, and so it works. It's a long topic. We can talk about it.
How do you want questions in the middle or the?
No, it's fine. Yeah.
And if you want to ask question, just ask for cache box.
So it's we have proved that this works, and that's how our customers do it. And then, of course, the question is why is it only 4 digits of PVV? Why not more? So I have a theory, that in the dark ages, there was actually the actual PIN number was written on this magnetic stripe, and then in order to keep the backward compatibility, the banks and networks decided that we can replace the same 4 digits with something less obvious. So they had this backward compatibility. They improved security by the means that there's no longer clear text PIN on the card, but there are still some rough edges around this and problems for this function. And if you aren't interested how I know this, then catch me later. I will tell you a story. Oh.
You're telling 4 digits, but you have circled 3 digits.
No. So it's so it's this circled is CVC or CVV value, and the PIN and PVV is somewhere on the second track. Okay. Sorry, I'm not an artist. So after this warm up, and I will return to this topic a bit later. So my name is Aivars. I work for company Tieto, and my ex-colleague reminded me then that an architect is a bad word. So let's say I just write code, and there's also a code on GitHub for this experiment with PVV values. And Tieto is itself a large company, but I work for a department that is retail payments and cards, and we produce a product for processing payment cards. We don't run the product ourselves. We deliver it to customers, and we have hundreds of them. And we also did some tests with Oracle, and we showed that our product can handle all transactions that Visa and MasterCard currently processes, like 10,000 transactions per second. And if you come we are always looking for new employees. If you come and apply for a job in Tieto, please tell that I told you to apply, so I get referral bonus. And now to the main topic. Before I start how the mobile phone can perform payments, let's look how a contactless card works in the terminal. So first you go to a shop, and the seller enters the amount you have to pay, and then you tap the card on the terminal. What happens there is actually within fraction of a second, there's a long dialogue and several messages are exchanged. So first, the terminal sends a command to give a list of applications. So it's not a well-known fact, but each card can have multiple applications on it. Typically, it has just one, but the protocol allows to have multiple applications on the card. And then card replies with some cryptic application ID, but the terminals recognize these IDs and know which IDs they support. So then the terminal says, okay, I will use your application. And card replies that this application is called MasterCard. It might be called Debit MasterCard or Credit MasterCard and so on. Then the terminal asks for some processing options. and card replies with some card profile and most importantly some file locations. So it can be thought of like names of files it contains on the card. Then terminal asks to read one file, which the first file usually contains this first like record contains card number, card expiration date, currency, country of the bank, and so on. Then it asks for another record with the location it received previously, and then the card replies with issuer's public key. Then another read request, and card replies with card's public key. And then finally, the terminal tells to generate a cryptogram to sign a specific instance of the payment with a payment amount and some other details. And card replies with most importantly something called transaction counter. And then there's some cryptogram. So all this happens within approximately 200 milliseconds. And then terminal sends all this information to the bank. Bank replies, terminal prints the receipt, and we are good to go. Also important thing is that there's no reply, there's no acknowledgement of the result to the card. That's why if you frequently use contactless cards, sometimes you are asked to insert the card into the terminal so it can get updates, because there is no feedback from the terminal. Okay, so this is the process. So what it takes to do the same with a mobile phone. And I have divided this task into 3 main points. Number 1 is to understand all the data that is exchanged, the formats and the protocols. Then there was something about certificate chain. And finally, something interesting happened when the cryptogram was produced. So let's look at each of these problems individually. First, data and formats. This is actually described by EMV specifications, and there are plenty of examples. And for me, this is a kind of like a simple task, because it's like read specification, look at some samples, and figure it out how to make it. There's nothing complicated. It's just everyday work for a developer. Now there's some public key infrastructure. So there's a kind of like a root certificate that is stored in the terminal. And typically terminals store the root certificates for MasterCard, Visa, Amex, and so on. So you can just come up with your own payment solution or payment card and make all the terminals accept it. You have to be either under MasterCard or under Visa, or you should have like some serious control of the terminal, so you can upload your own like root certificates to the terminal. So, and then this MasterCard signs like issuer certificate for specific BIN. BIN is typically the first 6 digits of the card number. And then there's a certificate for each card individually for a specific card number. So it contains the specific card number in the certificate. And well, here comes the problem. MasterCard just doesn't give you like, here, please, I will sign whatever certificates you give me. So MasterCard has some rules, regulations, how things should be done. And if you want to do payment from mobile phone by emulating a card, then MasterCard has something called MasterCard Cloud Based Payments, and you must follow it. There's no other way. There's, of course, some, in theory, you could do something, but it's not legal, and if MasterCard catches you, then you will be fined. So, and what this means for us is that it's not only we have to solve these three problems, we also have to solve some other requirements of MasterCard Cloud-based payments. and I will go into MasterCard Cloud Based Payments and explain also what it means for us. So first, okay, let's assume we're done with the certificates, and now let's look at the cryptography. So how this cryptogram is produced is that each card stores something called the master key, and then it uses application transaction counter. That's actually, I think it's 2 bytes, 2 bytes long counter that is incremented on each transaction, and sometimes it wraps around and so on. But the purpose of this transaction counter is to produce unique session keys, and that prevents you can't capture the traffic and repeat the same transaction over and over again. The bank at its own side ensures that this application counter keeps increasing, that it doesn't get the same transaction counter multiple times. So it produces a kind of like session key, and then by using the session key, it encrypts the data. And this is, so it works for cards. Now the question is, obviously this secret master key is very important, and how can we secure it? For payment cards, it's pretty simple. Cards have this chip, and it's not actually, it's a small computer, and there's a software running on it, and this software works according to strict protocol. So there is no operation to read all the content of the card. It replies only to specific commands with the specific data, and this master key is stored securely on this chip. But so this is simple for cards, and I don't know, this is from the title, these cards cost really little money. Now, what about the phone? And for phones, there are a couple of options. The oldest one, actually, the SIM card is also, we could say it's the chip. It's also a secure element that can protect some data. And then there are some phones used to have a built-in secure element, and some allowed to have a SD card that behaves like a secure element. But the main problem in this case is that phone can have only one secure element, and the main question becomes who owns this secure element. Because if you choose to use a SIM card, if you want to deploy some payment application on the SIM card, you have to go to mobile operator, and I'm sure there are a lot of steps and it's a long process to get something on your SIM card, and it's also not very convenient for consumers. I did a project like that, I don't know how many years ago, but it was, we worked closely with a mobile operator in Russia, and in order to be able to pay using a mobile phone, the customer had to go to customer center and exchange his SIM card. And it wasn't easy process, it wasn't quick process, because all the data, all your phone records and short messages you store in SIM card had to be transferred to a new SIM card somehow. Okay, so who owns the secure element? So that was the problem, and I think that's why these secure elements didn't catch up and didn't become popular. But then around 2011, kind of new technology was introduced. So this is description, I think, from Wikipedia. But the main point of it is that in your payment card, all this NFC antenna and controller is connected directly to the chip or secure element. And it was also the same for secure elements in your mobile phone. But now this host card emulation allows you to write application that sends data over this NFC controller. And it gives a lot more flexibility. And you can basically write and emulate whatever card you want and so on. But the question is still there, how to secure how to solve the storage of these master keys. And for MasterCard cloud-based payments is that they will put these HSMs somewhere on the servers in the cloud, and these HSMs will be responsible for securing the master key. So if we take a step back and look at how this EMV cryptography works, so the master key uses an application transaction counter to produce session key. For MasterCard cloud-based payments, what they do is they store the master key in the cloud, and then they generate like next three application transaction counters, produce 3 session keys, and then send these, deliver these session keys to your application on your mobile phone. And then each transaction consumes 1 key. So these keys are also called not session keys, but single-use keys, because they are can be used only for a single transaction. So they kind of pre-generate those keys in the cloud, deliver to your mobile phone, and your mobile phone consumes them. And if your mobile phone runs short of these keys, it requests new keys from the application. And so this is MasterCard solution. For Visa, Visa actually has a bit different approach. They have something called limited use keys, and that is the key is limited to be used for a day. There are pros and cons for each approach, but I think I don't have time to discuss that. So, but this is also not the correct picture. In reality, your servers will be located somewhere in one country, and your application might reside in another country, and there has to be a way how to deliver those keys securely from a server application to your mobile application. And the way how MasterCard solves it is it simply adds more HSMs. So what they do is simple HTTPS protocol. That means already encrypted protocol is not enough. On top of that protocol, they encrypt all the data with another, I think it's called management keys or so. So that's how they solve it. And if we want to comply with them, then we have to follow the same principles. But now, one more thing about MasterCard's solution is, you know what this is? Do you have something like this? So this is a wallet that protects your contactless card from paying by accident. And well, for mobile phones, it's a bit different, because in order to pay with a mobile phone, you have to at least unlock your phone. That means enter PIN or something, scratch your finger and so on, and unlock your phone. But MasterCard thought that this is not enough. So when they wanted to have PIN for such payments from your mobile phone, but there are 2 problems with that. So first one is that
you explained about session keys, but still, how to store them on the device? I mean, there's no secure way to store them.
They are stored encrypted, but of course it's possible to copy them. So risk is minimized by having a the bank can customize how many keys are stored on your phone each moment. So in case your phone is stolen, let's say, it means that, for example, they are risking only 5 payments.
Still, somebody can use it.
Yeah, it's still a risk.
And other application might use it.
No.
On the same device. Why not? If it's a fraudulent application running Android device.
Yeah, if it's a rooted device and so on. Yeah, so it's possible, but there's a risk, and you can evaluate how big this risk is. So you can limit and to have only a single key on your phone at each moment. So if somebody steals your phone, you are risking 1 transaction. But of course, then there's a problem if you go into subway and you don't have connection.
Airplanes as well.
Yeah, and so on. Yeah, so there are trade-offs, but you can balance that out. Okay, so about the PIN. Okay, how to secure the PIN? So in case we enter the PIN in the terminal, it's immediately encrypted and transported to your bank. And so here again we have problem how to store this PIN encryption key securely on your phone. The other issue is that there is no field where to send this, where to put this encrypted PIN, because this NFC protocol was initially created for cards, and cards don't, there's no way how you can enter PIN on your card. Okay, so the protocol doesn't have a field for encrypted PIN. How does MasterCard solve it? Well, they solve the first problem by using the same encryption principles. So they introduce the second master key that is used only for PIN. And it works in the same way, except when it produces the session key, PIN is subtracted from this session key. That's using simple XOR algorithm. And then when you enter PIN, the PIN you entered is applied to the key with the same XOR. And if you do XOR twice with the same value, you get the initial input, right? So, and if you enter the correct PIN, then it will produce a correct cryptogram. So, but now this is an additional cryptogram, and MasterCard had to come up with a way how to send that over NFC, and they were a bit creative. So normally cryptogram is 8 bytes long, and they found 5 bytes that were unused in the current message, and they told that, okay, we cut the script, cut off 3 bytes and send only 5 bytes in the message, and that should be enough. And if we remember the initial slide where only 4 digits were used to verify PIN, now it's 5 bytes to verify PIN, and it's highly unlikely there will be collisions, right? So this is kind of like good enough solution. It works. But okay, so there is this country. It's technologically advanced country, and it has Silicon Valley where all the innovation happens. But this country still works. The payment cards work like in the previous century. They still use magnetic stripe a lot. And but that's okay. It turns out that it's still possible to use contactless cards in the USA, and they have a special transaction type for that. It's called Contactless Magstripe transactions. And MasterCard also found a way how to transport this second cryptogram with PIN in this Contactless Magstripe transaction. So here's the algorithm. So basically it takes track 1 and track 2 of magnetic stripe, and then they put different bytes in different places, and they use a lot of words like recover, construct, and they limit this cryptogram to only 3 digits. So instead of 8 bytes, these contactless magstripe transactions have only 3 digits. So obviously it's well good enough. So MasterCard can work. But when you implement this algorithm and you try to pick bytes from different places and combine them together, whenever I did that, I was thinking about public transportation. And I'm really glad the same developers didn't work on this problem, because they would just stuff the people together and then reconstruct them in the final destination, right? So then another requirement that comes from the MasterCard is that we must use tokenization. So that means that for every card we use in payments from mobile phone, we actually create a proxy card. And actually this proxy card with its number, expiry date, and PIN is uploaded to your phone. And then there's a system in the background that handles the mapping from this proxy card to your real card. But there are also some great benefits to that. And the main benefit is that this you can configure the system so that this token card accepts only contactless payments with cryptograms, and it does not accept any other transaction. Well, if you work with cards, you know that card not present fraud is the biggest source of fraud. So it means that different transactions on the internet with low security are typically used for fraud. And there's no way how you can turn those transactions off for your regular card, because you might go to the USA and they have Magstripe, or you can rent a car and a car rental company might have imprinter where they put the card on the device and then and here a secure transaction in the 21st century. So this token actually increases the security by limiting the amount of transactions it receives, and the real card is known only to your bank. And as I said, since you have to comply with MasterCard, it actually says that implementation of this system shouldn't be a single system. It should be a set of 3 systems. So it's called Account Enablement System, Credentials Management System, and Transaction Management System. And they actually talk about 4th system that is called Token Service Provider. But luckily for us, when we did this project, we didn't have to certify this token service provider. So we kind of put this functionality into our transaction management system. And so what does each of these systems do? So account enablement system, MasterCard specifies what kind of APIs it should implement, and it implements APIs for users and cards to be registered in the system. And in the system, this system is also the main source of reports and UI, data for UI. It also generates the PIN, it generates the cryptography keys, and produces some data that will later be sent to your mobile phone. Then there's next system is credential management system. So this is the system that communicates with your mobile phone. And for these MasterCard Cloud Based Payments, it uses Google notifications. And so it sends all the personalization data to your mobile application, and it also generates these single-use keys or session keys. Then there's transaction management system. So this is the system that receives actual payment transaction from your phone. It receives like transaction with a token or proxy card. It performs all the validations and then produces a new transaction with a real card number. And so that's the main purpose. And then there's token service provider, which basically stores a mapping from a token to a real card. So I will show an example how a registration happens. So this is a bank system, but it actually might be as well a mobile application or internet bank. So first, because of the way MasterCard specified the APIs, first it asks to register a user. And at this point, it generates some random activation code that is stored in content management system for later use. And then this activation code is also returned back in the API. And then there's the second call that asks to upload, it's called to digitize a card. It basically means it takes your real card data and it creates a proxy card. So it generates some keys on the HSM. It sends card data to credential management.
Is there any difference in architecture if you use cloud HSM?
No.
It's going to be the same.
Yeah.
And the latency is going to be the same.
What?
Latency.
Of course no. Okay, so the cloud in this world, in this MasterCard cloud-based payments, if this system would be designed today, it would be called, I don't know, MasterCard vegan-based payments, yeah, because no animal products were.
I mean, in Azure, there is HSM provided as the cloud. So,
Yeah, I know, but this is actually stored in the bank's data center.
but not.
So cloud, it's just a buzzword. It might be vegan, whatever, diversity or whatever the buzzword is today. But yeah, good question. I will have 1 point for you later. So, okay, so it sends something to this, stores something in credential management system. Credential management system forwards the data to transaction management system. And by the way, this is flow how MasterCard specified it. So it's not our invention. We are just following specifications. Then this mapping from a token to a real card is stored in token service provider. And then at some point, user takes his phone, downloads application, and enters the activation code. And this credential management system verifies all the data and then initiates, it's called remote management session. So it sends a notification with the session keys to the phone, and then phone establishes kind of like a secure connection, but it's really HTTPS request with some additional encryption on top of that. So then it sends a request, and CMS generates some of these single-use keys, notifies that new single-use keys were generated to this transaction management system, and sends notifications to like reporting database. And so this communication happens until all the card data is uploaded to phone, and it has plenty of these single-use keys. Okay, and now what happens when you pay with your phone? So you tap your phone on the terminal. Terminal sends transaction to some payment system, and this payment system looks at the BIN number or the first digits of the card and decides that this is token for contactless payments on mobile phones, and forwards it to transaction management system. And transaction management system performs, verifies all these cryptograms. Both of them, first it ensures that the signature is correct, and then it ensures that the PIN number is correct. And if it's okay, then it looks up the real card number. It produces a new transaction with special flags into payment system. And this is where money is taken from your account. So if everything is successful, there's enough of money, plenty of money, then TMS sends the response for original transaction. And it also notifies credential management system that one of the single-used keys has been used, and that CMS should upload new keys to the phone. And then response arrives to the terminal. CMS, there are actually multiple of rules. It might look for minimum number of single-use keys and maximum number of single-use keys that are on phone, and decide when to initiate this management transaction. So it decides to initiate management transaction. Phone comes online. It generates new single-use keys, sends that to transaction management system, notifies reporting database, and so on. So that's how it happened. So that's how it works. And what the main difference between payments with a contactless card is that the phone always receives feedback from the system. It might come a bit later, but it still receives the feedback, and so there's no need to go somewhere and to like reset some offline limits in your phone. And of course, application then allows to display your real transactions and so. Okay, now I want to share some lessons learned from this project. Number one, so this seems pretty simple. So the correct way to spell MasterCard is either in capital letters or capital M and capital C. And because of that, we almost failed certification. We had to fix it. And then we started to think where this MasterCard with the lowercase c came from. And it actually came from MasterCard's own demo data. So MasterCard gave us incorrect demo data. And yeah. Then, so bugs everywhere. So we discovered a lot of bugs in MasterCard's own SDK for Android. And we had to fix that and deliver the fixes to the vendor who wrote the mobile application. We also discovered bugs in POS-terminal, and it was like a interesting bug because normally the card BIN number is 6 digits long. For some reason, we saw in the specification that 8 digits are supported, and we tried out 8 digits, but terminal declined. And of course, terminal didn't give any reasonable error response that, this BIN is too long. It just said no. And we spent a week trying to figure it out why it doesn't work. But finally we did. And then we also found a huge number of bugs in HSM firmware. And this is because MasterCard requires HSMs to work with JSON data. And this is something that HSMs didn't do before. So it failed on malformed JSON, it failed on JSON with extra spaces and so on. And we even found an issue that crashed our HSM so badly we had to go to this server room and reboot HSM and stand there and put in, when you restart HSM, you have to enter the keys again. So we had to put in 4 chip cards, and then enter PIN numbers 4 times for the device to come up. And then we actually crashed our HSM multiple times before we found where the issue is. And then was the funny thing that HSM vendor, he didn't believe that we have an issue there. And the thing was they offered HSMs in the cloud with the latest firmware for testing. So what we did, we actually switched our test cases to run against the cloud HSMs, and we crashed all the cloud HSMs. And then the vendor actually believed that, yes, there's an issue. We will try to fix it as soon as possible. And then there's something I call certification-driven development. And we actually wasted about 1 sprint, that's 2 weeks on that. And the reason was that when we looked at the specification, we saw that there's a functionality that should be together, but it actually is split between 2 of those systems. But logically, it belongs together. And if we split the 2 systems, there's actually some data that should be duplicated and some configuration that should be duplicated. And we decided to implement it in one system where it makes the most sense. But actually, when we looked at the certification questions, they specifically asked that part of this information should be produced in one system, part of that should be produced in a different system. And we decided that we can't argue with them during certification process that, because of clean code and clean architecture, you actually should group these functions together. So we went back and split this function as MasterCard wanted. And so on. This is something we used for the next projects. We first look at what the certification asks for and say that these are our boundaries, and then be creative and try to write clean and good code in the other parts. And then there are some lessons that can be learned from payment card systems. Number one is this backward compatibility. If you actually think about this, host card emulation came in 2011. I don't know when the contactless cards came, but the interesting thing is that the protocols that were created in the previous century that supported Magstripe transactions are actually capable of somehow working with modern types of payments, contactless and mobile payments. So this is a good thing. So this means that these protocols stay somehow or mostly compatible with the version that was 20 years ago and so. But at the same time, it also leads to a complete mess, and it's a nightmare to implement all this tricky logic. Like, if there's this bit is set to 1, then you, instead of taking data from the regular location, you take it from multiple locations. You combine it according to some algorithm and so on. So it's a nightmare to implement. It also severely reduces the security. As we saw with these cryptograms that should be 8 bytes long, they are actually reduced to just 3 digits. And the possibility might not be huge, but it's still possible to have collisions and to fake those. So that's all from me.
Questions? He's, or like I can see by his eyes, he's desperate.
At some point, you had a slide where there was a mobile phone, and then you referred to it as a card.
Excuse.
Yeah, here. You said the CMS transfers data to the mobile phone.
Yeah.
But we're talking about the card here, no?
No.
The mobile phone.
Yeah, mobile.
Okay, so if I switch the internet.
Switch off the internet.
And use the NFC for 10 transactions. Well,
if you have 10 single-use keys, then it's fine. If you have like 3, then after doing 3, you will get a notification that you should connect to your bank and get some.
No, I mean, so 10 is more than 3.
You decide how much you want to have.
Oh,
yeah, so it's configuration parameters.
Oh,
so
okay.
We started, I think, with 5,
Mm-hmm.
but the customer where we implemented that told that, internet is expensive here, especially the mobile data. So let's have like 10 or 15 these single-use keys, and they are willing to take the risk.
So you issue a new key per the configuration parameter?
Yeah.
Okay, yeah.
Jesse?
What is the difference from the customer's point of view between using Google Pay, Apple Pay, or your solution?
Not really, not much. So this is not our solution. So this is there's a MasterCard solution, and they have published the specifications, and they allow other vendors to implement the same system, and they certify that this system is compliant with their solution. So one of our customers, instead of purchasing this functionality from MasterCard, decided to buy it from us. So we implemented the same functionality. From a customer's point of view, I guess that MasterCard is accepted at more terminals than Apple Pay and Google Pay. So.
Okay, so my biggest question, probably the difference between POS and mobile phone is that POS have separate secure memory where all sensitive data is stored. But again, with mobile phones, we know that Android is not ideal. There still might be some bugs there that can allow to store the data. So from your experience, were there any problems with Android applications or iPhone, I don't know, with this solution? If it's not private data, or if you can share your experience.
Well, we didn't have security problems. No,
Okay, have you investigated any attack vectors on mobile phone? How you can attack your application and steal the data from it?
I think the point of this solution is that it's kind of like open to stealing data, but it limits the exposure to like certain amount of transactions. And typically, so at the point we implemented it, MasterCard required that all payments have the PIN number. And now in latest version, they allow for, low value payments to go without this PIN cryptogram. So if you steal the data, you still have to know the PIN.
But you can still PIN as well. I mean, PIN on glass, it's not 100% secure. So in case of POS, if you enter PIN, it's done by separate system. It's not the main OS which runs the device. It goes directly to secure memory, etc., etc. On mobile phone, you cannot have this kind of security.
Yeah, I agree. Yes, that's a problem. And in case of POS-terminal, it actually is kind of like secured in the moment you enter it, and it's transferred through the wire to the main. So you enter it in PIN pad, and then there's terminal even through the wire it goes encrypted. So I understand this, but like that's the solution.
The question is, have you tried to break your own system? That's my question.
Yeah,
so
we tried it.
Have you succeeded?
Well, during the testing, yes, but so what kind of attacks are we talking about?
I don't know. You design it. That's why I'm curious.
Yeah. So I don't know. So the risk of stealing data, that means that if you steal the keys, you kind of can, in theory, if you know the PIN, you can do a couple of transactions. So the phone, you can't clone the phone. It also checks some phone identifiers, but again, I think you can emulate that in software. So it's hard to tell. I think it's a less risk than somebody stealing your credit card. And I don't have a good answer to that, sir.
Going back to the question about the cloud HSM.
Yeah.
So your solution is using the hardware HSM.
Yes.
So did you consider using cloud HSM with the Vault because it's FIPS compliant now? The Vault Enterprise one? If you know what I'm talking about.
Yeah.
The FIPS 140 level 2 or level 3.
Yeah, so you shake the device or cut the power off, it erases all the memory.
And using the Vault, the HashiCorp Vault to do the storage.
At the time we wrote it, it was already challenged to find a vendor who implements the functions as MasterCard required. So we had a partnership with a specific vendor, and then we got solution there. So customer bought the HSMs, and
quite expensive.
We have quite expensive. Yeah, we have considered using. We have a couple of test cases of using HSMs in cloud. Yes, the latency becomes a problem.
So when you say they're using cloud HSM, so it's proven to be used by the bank or some other financial institutions.
I didn't understand.
When you say you have clients that are using cloud HSMs?
No, we tried it in our test lab.
Okay.
Hello. Hi, Aivars. This May I was in Barcelona, city of thieves, and this Mexican-looking gypsy junkie stole my phone.
Yeah.
And I'm fan of contactless phone payments.
Yeah.
Question: these guys here are very smart, but how smart should he be or his friends be to actually steal anything from me by having my phone?
Well, that I think it's a bit different kind of question. So
If he can unlock the phone, then don't he stop?
I mean, you speak about cloning the phone, getting the data that the master password cannot be protected. These things, I mean, how advanced should you be, like these guys here? Or is it?
Depends on the phone.
yeah. So they still have to know your, I don't know, either have your fingerprint or know your PIN to unlock your phone, and then they, in this case, they would have to know also your PIN you use for payments. So to do it like legally, I have a bit twisted mind now. I'm thinking how to like how to hack it, but
So older Android phones, you can clone them for
Yeah.
forensic purposes. So if you have a device, you need a specific device which asks for a lot of money officially. But for many models, you can do that, and the file system wasn't encrypted back then. If you're
Well-
using the latest Nexus Android phones, Android 9, Android 7, very much harder.
So one of the questions is, so we use Google notifications. In case of the clone phone, where does these notifications go to? Do they go to the original phone or the your clone?
Well, I mean, it's up to the point that he reports
Yeah.
that the phone was stolen. Obviously, once you report that the phone was stolen, you should be able to prevent the previous notification, just
Yeah.
rotate the keys and so on.
Yeah.
But if you haven't reported that, then technically for some phones, if you can't clone the phone, or if you can just access the file system because it's not encrypted, you can remove the PIN codes and so on. So maybe for older Androids, it was possible to just brute force the pins because they were short. So with newer phones, the situation is better, so it really depends.
So the question would be, how much should I worry? Because I was so surprised that I got something stolen.
So, okay,
Like,
you shouldn't
I'm from the same industry, but I was really confused. Should I worry or should I worry not?
You should worry that you have NFC enabled.
Yeah.
It's always in it. Because I pay with my phone.
You should report to your bank that your phone was stolen.
Yeah, I did that, but
And
I
they
mean,
should-
what's
they
the
should take
chances
care.
that he or somebody behind the scenes could actually clone the phone?
Skipujam šito.
If he can unlock the phone, then he can make at least a few transactions. And at least Swedbank has a limit of the transaction without PIN code.
Guys who are leaving, please give us feedback.
150 euros per transaction without PIN code. So you risk only.
Let's say he cannot.
Okay, I think let's have next session.
In that case, it shouldn't be possible.
Let's finish this one, and then we have a fourth session called Thief Summit, and then you can discuss it. And thieves and exploits.
So
yeah.
here's the topic for the next DevClub: how
Yeah.
to hack your phone.
Okay, should you next? Okay, Aivars, thank you.